See, there's one more problem on Riccati differential equation. Even if it is not given as Riccati, you should make it a point to write the model of the differential equation so that the examiner is clear that you're following a specific procedure, because every model has a procedure, right? So you'll be writing here, it is being given as Riccati, but even otherwise also you'll be writing it's a Riccati differential equation and start solving it. Okay. Let y is equal to v of x plus 1 by z. Okay. So y prime would, v of x is given to me as 1. So y prime is equal to v of x derivative, one derivative is 0 plus minus 1 by z squared dz by dx. I'll be substituting y and y prime in the given equation, given Riccati differential equation. Okay, so what I'll be getting is minus 1 by z squared dz by dx. This is equal to 4x into what is y? Y is equal to 1 plus 1 by z. Y is given to be 1, right? So 1 plus 1 by z whole square. Riccati is a non-linear because the dependent variable y is occurring in power more than 1. That's why it is non-linear. Student ought to know about what is linear and non-linear. Okay. So that if any printing mistake goes in the exam and you get a non-linear equation or which is not of the criteria that you have solved in the class, then you can be sure that it is out of syllabus question and need not waste time on it. 1 plus 1 by z squared plus 2 by z. Okay. Yeah. And then the second term I'll be multiplying 1 plus 1 by z minus 8x plus, minus 8x minus 8x by z plus 4x minus 1. Okay. There's a plus 1, there's a minus 1. You can just cancel out. Okay. Yeah. Minus 1 by z squared dz by dx. 4x also I'll multiply. 4x plus 4x by z squared plus 4 2's 8x by z plus 1 by z minus 8x by z plus 4x minus 1. Just see here. There's 1 plus 4, another plus 4 and a minus 8. Both all of them get cancelled. Yeah, there is anything else? There's an 8x by z and there's a minus 8x by z. That also gets cancelled off. Okay. So finally, again, for the higher order derivative, the quotient should only be 1. First order derivative is the highest order derivative. So I'll take my minus 1 by z square towards the right. So it will be minus z square. Okay. So dz by dx, this is equal to, yeah, here I'll be getting what? Minus 4x. Okay. And then here I'll be getting what? Minus z. Okay. Yeah, I'll be writing here minus z squared. So z and this will go off. I'll be having something like this. Now, dz by dx. Usually a Riccati's equation reduces to a linear differential equation, guys. And many of you would be aware of solving a linear differential equation. Even Bernoulli's is a bit confusing or difficult to some of you. But linear differential equation, it's very easy. I should write like this. Linear differential equation in z. Otherwise, I'll lose track and start writing y kind of things. Where p of x is equal to 1, q of x is equal to minus 4x. Okay. So what's the solution? How do I write the solution for a linear differential equation? First, I'll be writing the integrating factor. E power integral p of x dx, which is nothing but e power x. Solution would be what? Z into integrating factor. This is equal to integral q of x is minus 4x into integrating factor e power x dx plus c. I'll be using UV rule of Leibniz UV rule to solve this. Okay. Yeah. Z e power x. This is equal to minus 4 I can take out. This is u and this is v. All of you are aware, if you have seen my previous videos, how to apply Leibniz rule for integration. X into e power x's derivative is e power x only. X derivative is 1. Okay. E power x derivative is e power x. Okay. Any number of times you integrate e power x, I'll be getting e power x only. Okay. Yeah, right. I want the value of z. So I'll be keeping z here and taking the remaining terms towards the right. So minus 4x is what I'll be having. E power x by e power x na. So both of them will go off. Here also e power x by e power x na. Both of them will go off. C e power minus x will remain. So z value is what? Z is equal to minus 4x minus 1 plus c e power minus x. So how do I write the solutions for Riccati? That's very important. V is given to me as 1. 1 by z value is what? 4x plus 1. I can take out a minus common as well, guys. Minus I can take it out. Plus c e power minus x. This is how I will write the solution. If you can simplify it further, you can simplify it as well. Okay. If you can simplify it further. Otherwise, you can just leave it like this. 1 plus 1 by c e power minus x minus 4x plus 1. This is how I will write the answer for a Riccati differential equation. I think I am clear with the procedure of Riccati's. Okay, let's do some other model in the next video.